So first step is what infrastructure we have, what three machines we need, what operating system we will be using for this OpenStack Cloud Administration training. 20.0.4 server ISO download. Because I don't want desktop, I want Ubuntu server download 20.2. This is Ubuntu server and instant Ubuntu virtual machine. No, I don't want. I want option 2 manual server installation. I will be doing. I don't want ready machines. I never prefer that. So this is manual server installation. Download Ubuntu server 20.4.0. So this will start the download and this will be 1.2 GB machine. So once the download is complete, I will show you. This is actually you see live server. So I will be installing this and I will be installing Ubuntu on my desktop. It is quite fast, 20 seconds, 1.2 GB loaded. Wow, super fast speed. So in the meanwhile, let's do one thing. We'll create the machine. How to create the machine in this Oracle VirtualBox? You need to first set up the host network which is required for our cloud, that is a controller, compute and storage. 3 node cluster we will be creating. In the entire training I will be using this 10.0.0.1 and the second adapter I will be using this 203.0.113 that will be internally used by the cloud instances inside the cloud. So I need these two adapters of this series and let's create a new machine. First machine I'm creating is controller. Linux, we're going to Ubuntu 64-bit. So this is my controller machine. I'm giving it 6 GB RAM. I have total 12 GB. So it is recommended that you give at least 6 GB RAM to your controller. I'm creating a 20 GB hard disk. 10 GB, 20 GB is good enough for me for the controller. So this way I created the machine. Now let me go and check the settings of this machine. System will show you the processor, how many processors you have. So let's give at least 2 processor or 3 processor. Minimum 2 is recommended on official website of OpenStack. So I'm giving 3 CPUs to this machine. Display is good for me. Storage is where I need to insert the DVD. If the DVD is already inserted, import or downloaded, fantastic. It is imported. So let me go and delete the desktop DVD and move that downloaded DVD to this directory so that I have all my DVDs at one place. So this is my server DVD. So that's precisely we need to do under empty. We need to click on this icon, then choose disk file and select the DVD which you have just downloaded. And then this is hard disk. Audio we don't need. Network, yes, this is first adapter is NAT which will allow you to download the packages and install the packages. Adapter 2 need to be host only adapter. This adapter will allow communication between the machines. Adapter 3 will be the second host only adapter which we configured, which is adapter number 2. So this will for instances inside the cloud. So 3 adapter I configured. First is NAT, second is this, and third is this. Serial port I don't need, USB I don't need. Shared folder user interface is all good now. I can click OK. And now I start this machine. So this will start my installation of Ubuntu 20.0.4 server. So this is initializing my Ubuntu. Once it is installed, I don't need any GUI. I need only character user interface. So simple installation, only minimum installation is what I need. No error found. It will simply start the installation. Password expiry. Okay. So this will create public private key pair. Let's see what it happens. Ubuntu connecting. Yes. So select this. Done. So these are the IP addresses. We will check them later on, but right now if you want to go and change this, let's change it manually. Edit IPv4, and I don't want automatic IP, I want manual IP, and I want the subnet and address 10.0.0.0 subnet, okay, slash 16, and 10.0.0.11 is the IP address, 10.0.0.1 is the gateway. Name server is not listed, not required. Search domain is not required. Save it. So this is the IP address I want, and that's it from my side on the server machine. Proxy address nothing. Mirror is okay. Use the entire disk is good for me. This is a default disk. Set up the disk as LVM. Definitely I want that. Encryption I don't want. So it is all you see the default settings I'm accepting for the installation. Done. Are you sure you want to continue? Yes. So your name, I am typing my name. In fact, I want to create a user with the name stack, because I'm going to be work as server name is controller. Pick up a nickname, username, it is going to be stack. Choose a password for the user, and done. Ubuntu advanced token, if you want to enroll for this, enter Ubuntu advantage token if you want to enroll for the system. No, I don't want. Install of OpenSSH server is mandatory for SSH connectivity. Import identity, no, I don't have any identity, so done. So this is what popular mirror snaps for your server environment. Select or deselect with space. So I'm not selecting anything. This is Kubernetes for workstation, not need. Nextcloud, I don't need. So nothing, I don't need any of these right now. etcd, masquerade, I'm going to set them myself. Let's say PowerShell, I'm selecting. In fact, that's for Windows. I don't need. Why do I need it? So select. Right now, you can ignore all of them, and this will start the server installation. No GUI. When you are installing server, no graphical interface will be installed. This is a minimum installation I need. So once this machine is ready, I'm going to clone this machine, make the changes, and I'll create 3 machines out of the same machine. I'm simply going to clone that. So it will take time. Let it takes its own time. Now we'll start the lab requirement with the session. This is session 2. Understanding the lab environment. What am I creating? What my machine is going to be? That is Ubuntu 20.0.4 server. And I'm creating the machine in front of you right from the beginning. This is what you should be doing after this lecture is over as a lab assignment. Agenda of the session is OpenStack services and processes. Communication between services. Hardware requirements for our example setup. Security considerations. Host networking and example network architecture we are going to use. Identity service Keystone. Identity service components. Hardware requirements for controller, compute, block storage, and object storage from that perspective. Networking requirements. The queue, RabbitMQ. OpenStack compute components, and setting up the OpenStack cloud. This will be spread across multiple sessions, but this session is overview of these services plus what we are going to have in our environment. This is the OpenStack, complete OpenStack. Let me explain it. You start authentication with the Keystone. The Keystone service provide the auth. Ceilometer provide monitoring. Horizon is the dashboard or user interface. So you enter through the Horizon dashboard or from the command line. But yes, your process starts from where you are and you send your request through API. When you are planning to launch a job, suppose you want to launch an instance virtual machine. So how these services interact with each other? If you start from providing, you want to provision an instance. So your input goes to provision, operation and management of the virtual machine. So who will do what? Nova is your compute system, compute service. Glance handles the image service for your compute instances. Neutron is a networking service, virtual networking for your cloud. So Neutron provide virtual network or network connections for your VM. Ironic provide PXC network for your provisioning for your virtual machine. Cinder provides volume to your virtual machine. Swift stores images. Glance images are stored into Swift object storage. Even when you are taking the backup the database is in object storage, which is Swift. Orchestrates cluster via heat, that is stack service, orchestration service. So Glance is image service. Neutron is a networking service. Nova is compute engine. Virtual machine is what we want ultimately. Images are stored in object storage. Backup volumes are created again in object storage. Cinder handle the block storage, the volumes for your machines. So this is what various component or various services of OpenStack. OpenStack services and processes. Let me explain them in detail. OpenStack consists of several independent parts known as OpenStack services, which were listed in the previous figure. All services authenticate through common identity service named as Keystone. Individual services interact with each other through public APIs, except where privileged administrator commands are necessary. Internally, OpenStack services are composed of several processes. All services have at least one API process which listens for the API requests, pre-processes them, and passes them on to other parts of the service. With the exception of identity service, the actual work is done by distinct processes for the given service. For communication between the services, between the processes, there is one service, that is message queue service, that is message broker is used. The service state is stored in a database. When deploying and configuring your OpenStack cloud, you can choose among several message broker and database solutions, such as you can store it into RabbitMQ or MySQL or MariaDB. I'm talking about message broker and database solutions. This is the hardware requirement for us. What we are going to create right now, we are creating a controller node. I have given 6 GB RAM to this. If you noticed, I given 3 CPU. You can give 2 CPU. 15 GB is good. I give 20 GB. 2 virtual network interface card. I added 3, one for NAT and 2 for internal connectivity in the cloud. On compute node also I'm going to have similar, but then on compute node I'm going to use additional 2 disks, SDB and SDC. Additional disk will be used, and these disks will be used for my Swift object storage. That's what we need for compute node. The third node will be storage node exclusively for storage purpose, because object storage need redundancy in storage. It stores everything in copies, replicas. So therefore, same replica of the same size SDB and SDC, exactly same set of disk we require on object storage as well. So this is for object storage SDB and SDC of the same size we will be creating on storage node as well. For volume, that is center volume I am referring to, we will be creating another disk that will be SDD. So that means the storage will have a storage node will have 4 disks. SDB and SDC will be Swift, SDD will be cinder block storage, SDA first disk will be the main disk for the operating system. So this is going to be extra disk. If you look at controller node does not have any extra disk. Compute node will have 2 extra disk. It can have a third disk also for cinder block volume. I mean, if you want to create a block volume on 2 nodes, that is possible. But minimum is we need 2 disk on compute and 3 extra disk on storage, 2 for object storage and 1 for volume. Security. OpenStack services support various security methods, including passwords, policy, and encryption. Additionally, supporting services, including the database server and message broker, support password security. OpenStack and supporting services require administration privileges during installation of operations. Therefore, we must configure a user with sudo privileges. In fact, we will be creating a user which I already specified during installation, that will be stack user. I am going to give this user sudo privileges without password, and I'm going to create SSH key pair so that if I have to use this from remote machine, that is controller or compute, I should be able to use without password. So for example, some OpenStack services add a root wrapper to sudo that can interfere with security policies. The networking services assume default values for kernel network parameters and modify firewall rules. SE Linux is supported for RHEL or for CentOS, and write context to directories and files are mandatory when installing configuring OpenStack on CentOS or RHEL or Red Hat, I would say. Also, do not forget to open necessary firewall ports protocols if it is enabled. Host networking for our lab setup. After installing the operating system on each node, you must configure the network interfaces. Disable any automated network management tool and manually edit the appropriate configuration files for your distribution. All nodes require internet access for administration purpose, such as package installation, security updates, DNS, and NTP. My example architecture, which I'm going to use private address space for management network, and assume that the physical network infrastructure provide internet access via NAT. That's why I selected the first adapter as NAT adapter. The provider network. In the provider networks architecture, all instances attach directly to the provider network. In the self-service or private network architecture, instances can attach to self-service or provider network. We have both options. So we will have this option throughout our presentation and demonstration in the labs. We will be using self-service because provider network will have only the directly to the provider network, means physical network. Whereas in self-service, we have both options, self-service or private network. Self-service network can reside entirely within OpenStack or provide some level of external network access using NAT through provider network, which is ideal for us. So we are going to use self-service network. We are not going to use provider network. We are going to use self-service. And this is how it works. Tenant A virtual machine, and this is the IP address of the virtual machine. So if I use this virtual machine 2, and this is the IP address of this machine. The provider router, this is the provider network, provider architecture. This can be used to connect between the virtual machine of tenant B and tenant A. If you want to connect to the outside world, that is external network, so this router is connected to the external network as well with through this gateway, if these machines want to route the traffic to the internet. What we have, our environment is this. In my case, the controller which I am installing right now have this interface 1, which is 10.0.2.15, to be precise, not 10.0.2.10, it is 2.15, and this is what I configured manually, 10.0.0.11, and then this is connected to NAT, network address translation, to connect these machines to the internet. So this is management network 10.10.0.0/24, and this is provider network, which is directly connected to the net, connected to the internet, 10.0.2.0. Same thing I'm going to have on compute, 10.0.2.20 interface to similar 10.20.2.15 actually is going to have the same IP address interface, and then interface 1 and interface 2 similar on the storage node. Example network architecture I'm going to use is this. The example architecture assume the following networks: management on 10.0.0/24 with gateway 10.0.0.1, provider on 10.0.2.0/24 with gateway 10.0.2.1. Unless you intend to use exact configuration provided in this example architecture, you must modify the networks in this procedure to match your environment in our lab assignment. Because I'm going to use specific IP addresses, specific host networks, specific net addresses. So if you do not match, you will be having tough time in modifying all the labs with wherever required. You will be modifying all the IP addresses. Each node must resolve to other nodes by name in addition to IP addresses. For example, the controller name must resolve to 10.0.0.11, which I have already done, the IP address of the management interface of the controller node. Identity service Keystone. The OpenStack identity service, that is Keystone, provide a single point of integration for managing authentication, authorization, and catalog of services. In fact, before you start configuring any service, you will be creating the records in Keystone identity service for that service, and that is going to be mandatory. This service is typically the first service a user interacts with, as I said. Any request through command line or through dashboard is handled by Keystone first. Once you are identified, a token will be issued to you. So any request which you send to the cloud, like you want to launch an instance, the request will go to the Nova. So the request will travel with an authentication token. Every service will verify this token from Keystone before allowing you to use that service. For example, creating an instance or creating an image or creating a volume or storing an object into object storage or any other service. OpenStack, once authenticated, the end user can use their identity to access the other OpenStack services. Other OpenStack services leverage the identity service to ensure users are who they are, who they say they are, and discover where other services are within the deployment. Actually, that's what I was trying to explain with the help of token, because identity service creates a token for the user, and whatever request you send, whatever you do, you will carry your token. means your request will carry the token, and the other services will identify this with the help of the token only, because whatever request goes, the service will directly verify your identity through the token only. Users and services can locate their other services by using the service catalog, which is managed by the identity service, the Keystone. As the name implies, the service catalog is a collection of available services in OpenStack deployment. Each service can have one or many endpoints. In fact, traditionally, there will be 3 endpoints to each service. One will be internal, one will be for public, one will be for admin. So each service can have one or many endpoints, and each endpoint can be one of the 3 types: admin, internal, or public, as I said. In production, different endpoint types might reside on separate network exposed to different types of users for security reasons. Let's understand what am I trying to convey. For instance, the public API network might be visible from internet so that customers can manage their clouds. Admin API network might be restricted to operators within the organization that manage cloud infrastructure. Internal API network might be restricted to the host that contains OpenStack services. Also, OpenStack supports multiple regions for scalability. So actually a huge subject. So we will get a very good insight of OpenStack, how the services are linked, connected, and they are working. I guarantee that after you finish this course, you will be able to configure any service for that matter, provided you have required infrastructure, required hardware to support that service. As an example, if you are want to create physical machines through your OpenStack cloud, bare metal instances, physical machines, through that you need to have the physical infrastructure to be linked to the OpenStack. Then only you will be able to create it. Identity service components, server. Server is centralized server. It provides authentication and authorization services using a RESTful interface. Driver. Drivers or service backends are integrated to the centralized server. They are used for accessing identity information in repositories external to OpenStack and may already exist in the infrastructure where OpenStack is deployed, for example, SQL databases. Modules. Middleware modules run in address space of the OpenStack component that is using the identity service. These modules intercept service requests, extract user credentials. This is what I was talking about. Extract user credentials. I'm referring to your identity and your token, and send them to the centralized server for authorization. That yes, is it a valid user? I received this request with these credentials. Shall I go ahead? So the integration between the middleware module and the OpenStack component uses this Python web server gateway interface. Hardware requirement for the controller. The controller node runs the identity service, image service, management portion of the compute, management portions of the networking, various networking agents, and the dashboard. That's what we are planning to deploy, and we will be deploying it. It also includes supporting services such as SQL database, message queue, and network time protocol, that is NTP. Optionally, the controller node runs portion of the block storage. Optionally, I'm not going to have it, we are not going to have it. Our block storage will be dedicated on a storage server, not on the controller. Object storage, of course, we are not going to have it. But yes, orchestration we are going to have, and other services. The controller node require a minimum of 2 network interfaces. For compute, The compute node runs the hypervisor portion of compute that operate interfaces. By default, compute uses the kernel-based virtualization hypervisor. If you are using virtual machines, then you cannot use it because that is for physical machine. I mean, if you are working on physical Linux machine, then this is good for you. In my case, I'm going to create the entire cloud on in virtual environment. So KVM will not be applicable for me. I'm going to use alternative method which is QEMU, not KVM. The compute node also runs a networking service agent that connect instances to virtual networks and provides firewalling services to instances via security groups. You can deploy more than one compute node, and we are going to use controller and compute both for the compute service. Each node requires a minimum of 2 network interfaces. I shall be using this as object storage node also. For object storage, we need minimum 2 nodes. For this purpose, this node will have 2 extra disks, and that's what I give the example in the figure. If you recollect that, the same compute node we will be using for object storage, and if you notice that, yes, we added 2 extra disks on the compute node. Storage service uses storing accounts, containers, and objects. And block storage, that is my third node. The optional block storage node contains the disk that the block storage and the shared file system service provision for instances. For simplicity, service traffic between compute node and this node uses the management network. Production environment should implement a separate storage network to increase performance and security. In our case, we are not going to have a separate network for this. You can deploy more than one block storage node. We are going to have only one. Each node requires minimum of one network interface. Hardware requirement for networking. The provider network. That means if we are using physical network. This provider network option deploys the OpenStack networking service in the simplest way possible with primarily layer 2, which is bridging and switching services, and VLAN segmentation of network, that is virtual LAN segmentation of networks. It bridges the virtual networks to physical networks and relies on physical network infrastructure for layer 3, that is routing services. Additionally, a DHCP server provides IP address information to instances. The OpenStack user require more information about the underlying network infrastructure to create a virtual network to exactly match the infrastructure. This is our provider network, the controller node. So this is provider virtual network 10.0.2.0/24, provider physical network 10.0.2.0/24. So this DHCP namespace, which is going to be used by the virtual machines, and this is provider bridge. This is what I was talking about, the bridge between the two, virtual and the physical. And this is physical network infrastructure, which is connected to the outside world. Same thing is going to be on the compute node as well. For networking, self-service networks. The self-service option augments the provider network option with layer 3 routing service. Such that enables self-service networks using overlay segmentation methods such as VXLAN. Essentially, it routes virtual networks to physical network using network address translation. Additionally, this option provides the foundation for advanced services such as load balancer as a service or FWOS as a service. The OpenStack user can create a virtual network without the knowledge of underlying infrastructure on the data network. This can also include VLAN, virtual LAN networks, if the layer 2 plugin is configured accordingly. So this is self-service network. We are going to use, as I said, we are going to use layer 3 and VXLAN. So this is Linux bridge. So it has option to physically connect also, virtual Ethernet card. And this is DHCP namespace to provide the IP address to the virtual machines, and interface 3. And this is physical network infrastructure. This is network node, which we are going to be, in our case, is going to be the compute node. So this is provider network aggregate. This one, this is provider network VLAN untagged, and then overlay network, and this is self-service network. So this is self-service network, means virtually this is self-service network, blue color. So this is self-service network we are going to have with layer 3, L3. The queue, how these packets or requests are traveling. This is a central hub. This is handled by central hub. A central hub for passing messages between the daemons. We shall be using RabbitMQ, that is the Rabbit message queue, as a message queue service. It will be installed and configured as a prerequisite on our controller node. OpenStack compute components. MySQL database stores the database, most build time and runtime states for cloud infrastructure, including available instance types, instances in use, available networks and projects. Theoretically, OpenStack Compute can support any database that SQL Alchemy supports. Common databases are SQLite 3 for test and development work, MySQL and MariaDB. We are going to use MariaDB. Day-wise schedule. If you look at, I complete this curriculum in 5 days. So if you look at 5 days, every day we have 2 sessions and 2 labs. So lab 1, every lab take nearly 1.5 hours to 2 hours. So nearly 4 hours of lab assignment and 2.5 hours of theory. That makes it a 6.5 hours. If you add 1 hour for lunch break and 2 tea breaks of 15 minutes each, that makes it total 8-hour session. So lab 1 is you will be doing installation of Ubuntu 20 or CentOS 8 and configure network interfaces and NTP. Lab 2, you will be installing cloud packages, MariaDB, RabbitMQ and Memcache. Day 2 will have 3 lab assignments: install and configure Keystone, install and configure dashboard, install and configure image service class. This is going to be lab 3, this is lab 4, lab 5. On day 3, if you look at from day schedule, if you are attending a 5 days full program, then lab 6 is install and configure Nova on controller node, and then install and configure Nova on compute node, and then install and configure Neutron. Lab 9 will be install and configure object storage Swift. Lab 10 will be install and configure Cinder. Lab 11 will be install and configure orchestration Heat. In your case, it will be lab number 12, which will be install and configure Ceph storage. And then there will be extra practice on devstack also and upgrade process. So OpenStack Cloud hands-on, these are the lab assignments as I discussed. That's all for this session. Let me continue with the installation process. So here we are. The installation started. Installing missing packages. So view full log, reboot now. Our installation is complete. If you notice, we did not do anything. And now we can unmount the DVD if it is already mounted. It is already unmounted, so I can reboot. So I can simply reset it. Ubuntu 20.0.4 server is installed on this machine. DVD is removed, and this is Ubuntu 20.0.4. So I will be cloning this machine. Before proceeding, I'll be creating 3 machines out of the same machine, and then I'll be adding extra disk to convert them into controller, compute and storage node. So once my machine starts, I'm not going to do anything. will shut down this machine, log in and shut down, and then after that I'm going to clone this machine to have 3 machines. So the installation part is discussed in this session. Setting up the 3 machines with all the prerequisites will be done in the next session, which will be demo only. So next 2 sessions will be lab assignments, which means essentially there will be no theory next week as we discussed. So it will be only the hands-on lab assignments. So we will do it together, and the recording will be available for you on the session in the website. So let me finish this. Is configuring job is running for wait for network to be configured. Let it finish. Yes, I can log in as stack. I'm logged in. So this is my machine logged in as stack sudo su hyphen. Hopefully it will work. I give the password as stack. Yes, I'm logged in. So this is my simple machine. I'm powering it off now, and I'm going to create a clone of this machine. So I'm going to create 3 machines from the same machine. This is a controller, compute, and storage. So how do I create clone? That is available here. Right click, clone, and this is going to be my compute. Of course, additional disk and everything else will be added. So compute, this is how you clone the machine. So you'll get a copy of this Ubuntu 20. So you'll get 2 machines. Similarly, you will create, so once the clone is finished, I'll be creating another clone, and that will be my storage machine. So that's about the installation of Ubuntu 20.0.4, and that's all from this session. See you in the next session. Thank you.